Nick Krippner, and we're here this morning to give you a presentation on our Tideflex engineered systems. And so a little housekeeping first. Please ensure your audio is working via Zoom, and then type your questions in the Q&A box, and we'll answer them as we go through the presentation or afterwards as well. Okay, next slide, please. Okay, the agenda for our discussion today is, first we'll have an overview of the Tideflex engineered systems. Then we talk about the expansion and additional resources that have been provided to this expansion. Then we'll go into the coarse bubble mixing systems, hydraulic circulation mixing systems, grid fluidization systems, and then some applications and positioning opportunities. We'll focus on some recent big wins, and then some new or updated sales tools, and then the expectations for customer engagement moving forward. Next slide, please. Okay. The first thing you'll notice is I think a new name for this group, and that is the Tideflex Engineered Systems Group. And that particular name refers to all of our mixing systems collectively. So we have the stormwater and process wastewater mixing systems, the clean water mixing systems for water storage tanks, and the wastewater effluent into river and ocean mixing systems. So it's also the name of the Department of Design and Sales Operations Group. This department is responsible for the engineering and the quoting and order management of mixing systems. There are three main groups of mixing systems, each targeting a specific fluid type. So those the stormwater and process wastewater mixing systems cover the products within those are the coarse bubble mixing systems, hydraulic recirc and mixing systems, and then the grit fluidization systems. Then on the clean water end, in the group for water storage tanks is, of course, the potable water mixing systems, or the TMS. And then the group under the wastewater effluent and river ocean mixing is the Tideflex effluent diffuser systems. And in those groups, along with the engineering end, is the sales contact for the coarse bubble and the hydraulic recirc and the grit fluid is Jeremy Gill, and the engineering contact is Jeff Kelly. In the TMS group, sales contact is Joey Laboda and Kevin Stoltz, and the engineering contact is Chris Chinette. And then on the effluent diffusers, the inside salesperson is the person that you now deal with for your specific territory. And again, Chris Chinette handles the effluent diffuser systems. Next slide, please. Okay, we mentioned Jeremy. Jeremy has been behind the scenes strengthening our technical support for about a year now. He's exclusively dedicated to this position, in this product line, bringing hands-on support to all the major product opportunities. Most of you might remember Jeremy, be familiar with him. He did 7 years. He was the Deseric Senior APCO uh, applications engineer. He's he has been working with Jeff behind the curtain now to learn this mixing technology and to optimize some of our sales ops systems. This position frees up Jeff Kelly from some of the sales ops responsibilities so he can concentrate on applications, design, engineering, and sales to grow the business. This position accelerates the sales cycle with advanced technical validation and increase in design proposals will lead to more orders. It helps us deliver best-in-class technical responses and eliminates some of the gaps that our competitors have, and also improves and speeds up the order cycle. It drives what we're really looking for in this revitalization is this hire reflects our commitment to scaling this product line and capturing a larger market share of high value projects. Next slide, please. Okay. What we've also done is trained our regional sales managers to be able to sell this product and just put more boots on the ground out in the field, supporting you in our sales effort. So what we did was we've been training the regional sales managers in all of the wastewater mixing so that they're able to deliver first class presentations to your customers, brown bag sessions, lunchtime sessions, or any type of a presentation that you just need to generate the application data forms. So that's what they're going to do. They're going to try to entice the customers to want to take it, that to get an application data form filled out, and then that'll get forwarded on to Jeff, who will look at the application and provide very good technical expertise, a very nice report, and also determine what the design might look like, work on budget pricing and that kind of thing. So we know if we can increase the number of application reviews and increase the number of these applications forms, that's really the key to increasing the business. So instead of Jeff just being the one out there doing it, or just by webinar or whatever, the regional managers are there to help you sell the product. Next slide, please. Okay. The reason that we are doing this is because we've had 3 years of really steady sales growth, and it's really grown tremendously. But the market is really driven by us. Really don't have any competition, and so we believe that if we increase our resource, then our sales resources apply to this and be able to grow the business by doing that. And Jeff was doing everything from engineering to application engineering to production, scheduling to selling, in both webinars and personal sales calls. And we realized that to grow this, we had we had to scale it. We had to scale it and fund it and provide make it into a scalable product that we can continue to grow. With one person, you just couldn't do that. So we took a hard look at this, and you'll see some of the things that we did, and really, how much we grow this is just limited by how much we can get out and do it. So the technology is already proven, and obviously, but it's a great product, very reliable, maintenance free, all stainless steel, self-purging, non-clogging. But it just we were limited by how much one guy could do, so we needed to fix that. So we really invested a lot into it. Next slide, please. And really, I think one of the important things to understand, obviously, to you all is why do you want to sell this? Well, once you get it specified, there isn't really any commission or any competition. So the commissions are high. They're usually large projects, anywhere from a couple $100,000 to several million. The one, and this is important too. Just a couple of housekeeping things. This does not compete against fine bubble aeration. It's not the same purpose. When somebody thinks about aeration systems, they're usually thinking of putting more oxygen into the fluid, and while that is a side benefit of coarse bubble mixing. Coarse bubble mixing is really better at getting a flow going in the system with the buoyancy of the bubbles for mixing, not really to oxygenate the fluid, although that's a side benefit. But whenever we start our presentations and talk about aeration mixing, everybody goes immediately to thinking that's fine bubble, and so there's a lot of confusion when we use aeration. So we're getting away from that to differentiate us and better explain what our product is. So we're going to talk instead and change, move away from calling aeration mixing and just call it what it really is, and that's coarse bubble mixing. And also want to say today we aren't really going to have the time to cover the TMS and the effluent diffuser systems, and the clean water mixing and the diffusers into the rivers and the ocean and so forth. We just won't have enough time to cover that today, but it doesn't mean we aren't focusing on them. Doesn't mean they aren't great products. Red Bev developed them and continues to lead the industry in expertise, experience, market share. TMS just quickly it eliminates thermal stratification in potable water storage tanks, and the effluent diffuser systems are a cost-effective means of achieving high initial dilution of discharge effluent with submerged nozzles to more quickly provide initial very spread out dilution and allow to help the environment at the discharge point. It does that through multiple submerged multi-port diffusers to minimize the impact of these discharges on the environment at the area of the discharge. So the I think that is it for me. So next slide, please. And I'll turn it over to Nick.
I believe I'm up.
Oh, you up, Jeremy? Sorry.
But good morning, everybody. As Don mentioned, today we're going to be focusing on that TAD group of the Tideflex engineered systems. So that's going to include both coarse bubble and hydraulic mixing, as well as that grid fluidization. So these systems are designed to keep solids suspended while preventing wastewater and biomass from entering in the distribution system. So this is very critical to ensure that we can have continual operation of the system. Again, no downtime, low maintenance. So how do we do this? We take advantage by utilizing over 50 years of Tideflex duckbill check valve technology. So with this, each diffuser is going to have that duckbill that's going to prevent that backflow, automatically self-purge the condensate that builds up during operation, all while preventing clogging in the distribution manifolds. Another key performance feature in our coarse bubble mixing systems is that the air discharge location is just within a few inches from the floor. So now if you notice, especially with fine bubble diffusers, they're always on top of the piping. This means that from that elevation to the tank, there's nothing that can get those solids suspended up and moving. So that's all just going to settle there. With our design, we have these pointed towards the ground. So this is going to help the solids from settling on the bottom, and it's also going to maximize mixing energy. Again, with this check valve design, we can also operate the blowers in an on-off mode. So with this, we can improve biological performance while also reducing energy consumption. Lower energy consumption obviously equals lower operational costs. Now in hydraulic recirculation applications, we call them mixing nozzles instead of diffusers. And now these nozzles are going to act as a variable orifice. So they're only going to open as much as needed based on the flow rate, which allows the system to maintain maximum discharge velocity at any operating condition. This is important because fixed port nozzles can't do that. They're going to lose velocity as the flow decreases. So now the next slides and the rest of my section is going to highlight where these systems are most commonly applied. And honestly, this is really where it gets exciting because no matter your guys' territory, the opportunities are out there in a big way. So we really want to tap into that market because we think the opportunities are endless. You want to go into the next slide, Nick? So one common application we'll see is stormwater containment tanks. So now these tanks are usually installed in areas where there's heavy runoff, where regulations are telling the engineers that they need to capture that initial surge of stormwater. It's really about that first flush. They don't want it surging their systems, and because that can lead to many issues. But by temporarily holding this water, municipalities can monitor and determine whether treatment is needed before discharge. And they can also manage those peak flow surges that could overwhelm the wastewater treatment facilities. Now, with this stormwater, as it collects, it's not just going to be clean wastewater. It can contain solids, debris, bird poop, turtles, etc. So when this gets held for extended periods of times and days, these conditions can quickly turn that tank anaerobic, which can lead to some bad smells, odor generation, and some downstream process complications. So by maintaining proper mixing, we're able to prevent stratification and these septic conditions. This is also where the maintenance-free mixing is ideal. And using this mixing system, we can help keep those solids suspended while preventing buildup, reducing those odors, and having consistent tank performance without the need for mechanical mixers, which again is just going to save us on energy costs. Now, as we move towards the wastewater flow equalization tanks, here we're going to deal with influent. Now, influent to a plant naturally is going to fluctuate throughout the day. Typical peaks we'll see, in the morning, evening, or in case you got a Super Bowl down the street, a lot of people are using the toilets. So when you're seeing this high water uses, you can create high surges that are going to create variability in the hydraulic loading to wastewater treatment plants. with any biological treatment process, they're going to perform under stable conditions. So by using these tanks and basins, they'll act as a buffer between the collection system and the treatment plant. So these tanks can store that excess flow during the peak periods and release it at a controlled, consistent rate to allow the plant to operate under steady state conditions. Again, this is wastewater. So we're going to have all different types of media in that material. So we want to maintain those aerobic conditions to prevent that septicity, the odors, and process upsets. So maintaining that constant mixing is required even as the tank volume fluctuates. That's another advantage of our design, because with our design, we can operate reliably in variable volume environments. So utilizing our systems in these types of tanks helps prevent problems instead of reacting to them later. Next slide, please. So as we move further into the wastewater treatment process, we get to the preliminary treatment stage. Now in this stage, you're going to find heavier inorganic solids that we like to remove in these systems. So in some larger facilities, it's common to see multiple aeration basins interconnected by shared influent distribution channels. A lot of times these channels are rectangular in cross section, and this is all to provide a greater hydraulic conveyance that capacity than closed piping when transferring high flows. Because this common channel feeds each aeration tank, isolating one of these can be a challenge. So this is where our design really comes in handy. If you're to take a look at any of these images, you can see that from the drop pipe leg, there's a tie-in, and then you see a manifold with 8 to 10 diffusers. So our drop tie legs are completely removable, and that's great for maintenance. In case one of these diffusers goes wrong, you don't need to send someone down there. You can actually remove the whole assembly by lifting it straight up and out and replace as needed. Only thing you need to do would be close off that isolation valve that's providing the air, and it's really relatively easy maintenance. For aerated grit tanks, this process is designed to remove dense inorganic materials like sand, gravel, and other grit before they move downstream. So this is commonly where we'll see it too. And then in a rectangular aerated configuration, the air is introduced to create rapid mixing. This motion is going to keep the lighter material up on top, where that heavier grit falls to the bottom so it can be collected and removed. Proper hydraulic balance is critical. Too little mixing will allow a lot of organics to settle with the grit falling to the bottom. And if you have too much mixing, we're going to knock all that heavier stuff up to the top. So it's really important to get that ideal mixing point. Next slide, please. So as we move along the solids handling process, we also apply these systems in sludge storage tanks and aerobic digesters as well. So these basins are going to manage waste activated sludge and other residuals that get removed during treatment. Another trend we're starting to see in modern wastewater treatment is a focus on bioselection, which is essentially about promoting the growth of beneficial microorganisms while suppressing unwanted ones. So by maintaining the right environmental conditions, facilities can support a healthier biomass, which is going to lead to improved digestion performance, a better process stability, and reduced odors. Another way to remember bioselection is it's really about controlling the bugs. Good bugs will do the treatment, whereas bad bugs can create more problems. And consistency in mixing is really what drives performance here. Next slide, please. So to this point, we have discussed the coarse bubble mixing with aeration. So now we're going to shift our focus onto hydraulic recirculation mixing systems. So in some processes, introducing oxygen is actually bad for performance. A primary example of this would be nutrient removal anoxic zones. Anoxic processes depend on maintaining very low dissolved oxygen levels to support the denitrification biology. So conventional aeration-based mixing methods will introduce oxygen, and that's not good here because that can disrupt the microbial pathways that are required for effective nutrient removal. So with hydraulic recirculation, we can provide the necessary mixing and solid suspension without compromising the anoxic environment. These systems are also beneficial where sometimes blower infrastructure is not available, or sometimes blowers are just too expensive, but they happen to have a pump already there. So by using that internal hydraulic energy instead of constant air supply, facilities can still achieve that mixing they're looking for with significantly lower energy and equipment requirements. Also, hydraulic recirculation systems are going to provide directional longitudinal mixing, which is an important feature in tanks containing heavier solids. So with this type of system, you can get mixing without hurting the process. Next slide. So grit fluidization systems are intended to influence settled grit in a specific area to fluidize this grit so it can be moved out of the alkalinization area by hydraulic flow in the tank. So these settled grit blankets are very dense and require a lot of energy to move. So with these hydraulic nozzles, we can orient them in any specific direction to discharge the high velocity fluid to get that stuck mass to move and fluidize that settled grit and push it along where we want to. Again, we have those variable nozzles. This is not going to be a fixed port nozzle, so we can get that optimal discharge velocity. Next slide. So from a positioning standpoint, the most effective strategy is going to be first to identify the consulting environmental engineer who's going to be designing these mixing systems for wastewater facilities in your territory. Why do we want to do this? Pretty simple. Engineers are going to write the specifications. This is a phrase most of you have probably heard before, but again, it's all about stacking the deck in order to win on bid day. So it's very important to get out and meet with those engineers to allow us to understand their project drivers, the constraints they're working with, their design preferences while positioning our solutions at the specification stage rather than after bids are released. Again, we want to get out there and help them write their specs. So this initiative is really about building confidence and consistency in the field. So RSMs are going to work alongside you guys to present and deliver these presentations and support conversations with engineers. They're going to start the conversation. From there on, when it starts to get more technical, that's when we're going to bring Jeff Kelly in and really just examine their project. So this is going to ensure that the message is accurate and application focused, and it's going to help your guys' team get comfortable leading those discussions on their own over time. Again, if we're in the spec, it's easier to win the project. Next slide, please. In the diffused aeration space, specifically coarse bubble, there really are very few systems that operate at the top end of the performance. So due to this, it's really to our advantage and the end users that we get engineers to move away from the traditionally named manufacturer specifications and work towards a performance-based specification. So many of you have likely seen this, but Jeff has created 10 key core points of specifications that we send out when engineers are just wondering what we're talking about. But these are really strong specifications that engineers really enjoy. This is because engineers don't just want components, they want the results. They want to see that the process is working and why it's working. So by getting them to define how the system must perform and then requiring all proposed systems to be evaluated against that criteria, the comparison becomes engineering driven and just not brand focused. It's all about the outcome. So here's the key point for you guys as partners. When performance is key, the Tideflex engineered systems are consistently going to rise to the top. We're not just selling another diffuser option. We're not just looking to sell a valve. We're looking to really sell our system and the belief we have behind it. From a hydraulic mixing and durability standpoint, there effectively is no performance equivalent competitor in this category. Some engineering firms have already realized this, and I see this more often from time to time. Engineers always want to list an or equal or approved equal, and they'll try to, and sometimes they even ask us who to list, and they run into the problem because there's really not that many systems that can match the combination of our mixing energy transfer, the non-clogging operation, our low maintenance profile, the durability, the on-off blower operation, and long-term performance stability that our system can provide. Next slide, please. So now, this was previously mentioned a little bit earlier. This is about the application data forms. So for those of you who remember when I was running the basic surge investigations at Zurich, it's a similar process. So online we have these Tideflex engineered systems data sheets, and there's 3 different types of systems. We'll have ours for the course bubble. We'll have ours for the HRMS. TMS has their own as well. For us in the TAD group, the objective is to get into contact with that environmental engineer, hear about some upcoming projects, and get them the correct data sheets they need in order to fill out so we can help them design a top-tier system. Again, this probably sounds familiar. So now once we receive a completed design data form, the process immediately shifts from being a sales sort of thing to engineering validation and system modeling. So this step is critical because every design proposal we do is based on calculated system performance. It's not based on a rule of thumb or generic layouts. Jeff is going to take the data that you give them. He has an Excel program that he can run. And with this, it's going to be completely set for their specific system. So this completed form is going to be that input data set for our internal design model. And yeah, again, this is just another tool we have to offer. It's a multi-page engineering tool that's going to integrate all the project-specific parameters into a single performance-driven design workflow. Now, with this, again, all of our proposals are going to be backed by a documented parameter-based model that ties system configuration directly to performance outcomes. This is going to provide credibility for you guys, credibility for us with consulting engineers, and it's going to reduce the risk for end users. When we're able to position this process correctly, we're not presenting a product quote, we're delivering an engineered system designed by backed performance calculations. Not only that, we also, Jeff and his team, Tideflex Engineering, we're going to develop the arrangement plan in AutoCAD and supply this file to the engineers too, so they can insert it directly into their contract plans. So these are full-scale designs. They're not just dimensions. Again, these are going to be based on the drawings that they're able to send us, the contract sets. We'll plop them right into there. So now when you combine this performance-based specification and this engineered design support, it's really what's driving such a high success rate for our systems. Now, Nick is going to dive into some examples that show just that.
Thank you, Don. Thank you, Jeremy. As Don mentioned earlier in the presentation, these can have some large dollar values. Jeremy got into the performance-based specs. If you can get those in, you're pretty much in a sole source situation. And going over the last couple years of how this brand of ours has scaled and grown and how we're going to continue to grow. We've got some recent big wins over the last couple years that we want to share with you guys to just give you some context. First project we want to highlight is at the GE Booth wastewater treatment plant. This was done a couple years ago, located in Ontario, Canada. Syntec Process Equipment being the representative for that territory. This can kind of show you how big the scale can get on some of these. This was a channel mixing project, and based off this wastewater treatment plant, there was over 325 coarse bubble mixing assemblies that were procured during this project. And with those systems, over the period of time, the project total exceeded over $4 million. So, as Don mentioned, some of these, if you're just doing one or two sections, they can be, in the 20, 10, 20, $50,000 range. But if you can get a good spec written on a big rehab or a new plant or however it comes to market, the size of these projects can get quite large. So that was the first project we wanted to highlight. Second project we're going to highlight is a project at TRRWA. That was an upgrade project that was located in Washington State. Antec Corporation was the local representative for that project. And this was a quantity of 4 coarse bubble mixing systems at their plant. The ability to get this in a great situation. The rep did a great job, and doing it 4 times over. You look at that, and you're over around $150,000 a unit times 4. You can get to $750,000 pretty quick. Last project I want to highlight is at the OSO wastewater treatment plant. This was another upgrade project located down in Corpus Christi, Texas. The local representative there was Environmental Improvements, EI Squared. This project was kind of in phases, and these phases shown on the screen was a quantity of 8 channel mixing systems, all 316 stainless steel construction, for again a project value of approaching $1 million, around that $750,000 range. And what's really nice about these upgrade projects is that once you can get one in there, and it pretty much performs for itself, the end users see that. And this project alone, being in Texas and in my territory, we've seen probably 4 to 5 now different upgrade phases of this plant. So it's kind of the gift that keeps on giving. We were successful on, getting them to go with our technology. Our technology was installed. It had proven success, and they're looking to expand it through to their entire plant. And they want the coarse bubble mixing systems from Tideflex Engineered Systems, and they really don't want anything else. So as we push into our next phase of growth, our ability to articulate value quickly for these systems is everything. Whether you're at a conference or walking into a customer's office, you'll often get 1 minute, maybe less, to make someone care about what we offer. Having a tight, confident elevator speech is not optional. It's really a growth lever. We're not trying to teach these Tideflex Engineered Systems in 60 seconds. The goal is trying to create the curiosity, establish the differentiation, and really earn that next conversation. For engineers, from a design standpoint, it simplifies maintenance assumptions and long-term life cycle costs. For the operators, this is really about eliminating daily headaches, get rid of that clogging, no constant maintenance. And then for the decision makers, the end users, the municipalities, you're reducing their energy spend while they're investing in a 30-year asset. It's going to last for a long time. During first touch points, we really want to avoid over-explaining how the system works mechanically. And if the customers remember one thing, it should be this system really reduces maintenance, saves energy, and it lasts decades. Our team internally has worked together to launch a new sales guide manual that will aid and align us on how we win in this market. We're not selling equipment. We are solving operational problems. Conversations should tie back to reducing operating costs, eliminating maintenance, and providing long-term reliability. If you focus on those outcomes instead of features and benefits, you'll differentiate yourself immediately. This guide highlights product line sales, sales development and strategies plans, application flowcharts, sales tools, multiple frequently asked questions with factory responses, and installation and field test certification procedures. All right, next slide here. We're going to really highlight one of the most underutilized growth assets we have, our past installations book with a multitude of references. This is not just a marketing piece, it's the proof. And in sales, proof converts faster than persuasion ever will. Some representatives use this book too late in the process, or honestly, sometimes not at all. It's sometimes treated as a leave behind instead of what it really is. It's really a tool to build trust early and eliminate the risk throughout the sale. Every one of those installations represents a customer who had a problem, made a decision, and saw the result. That means for almost every prospect you speak to, there's already a story in that book that mirrors that situation they're going through. Our job is to connect those dots. When presenting, we don't want to just flip through the whole book. Be selective, look it over, pick 3 to 5 highly relevant examples that are for that application. And when objections come up, and they will, this is where the book really earns its value. Instead of defending the solution, you show them the others who had the same exact hesitation they did, and we can move forward successfully. At the end of the day, engineers and end users don't just want to know if something can work, they want to know if it has worked. For someone like them, and we already have that evidence in this 11 by 17 installations book. Shifting gears a bit, we'll talk about another high impact tool, our newly developed technology reference book. This is not a sales brochure. This is a technical authority piece. It's built on multiple white papers, grounded in engineering principles, and specifically designed to elevate how we sell, especially when we're in front of technical buyers, the consulting engineers, and the decision makers who care about how and why things work. In other words, this is the proof behind the proof. You're not expected to become engineers overnight, but we do have the ability to leverage the technical credibility to build trust and to separate our competitors who stay surface level. Early in the sales process, this book positions you more than just a vendor. It allows you to say, we don't just install systems, we understand the science behind why they perform. Because when you combine real-world installations with technical authority, you're not just credible, you're undeniable at that point. All right, let's talk about another powerful tool that we can put in front of the customer. Our relatively newly created 2-nozzle demo built from actual production components. This is where we move from talking to showing. Because at the end of the day, prospects hear a lot of claims in this industry, performance, efficiency, durability. A lot of people say it. What separates us is our ability to physically demonstrate it using the same components that go into real-world applications. Like I said, these are not mock-ups. These are not simplified models. What you're holding is real, field-proven equipment, and that matters because it immediately removes doubt around the performance. Now, strategically, this demo should not be an afterthought. It should be a centerpiece. Early in the conversation, it creates the curiosity. It gives you the reason to engage and say, let me show you exactly how this works. That's a very different dynamic than flipping through, presentation slides, bulletin, brochures. So as you walk through the demo highlight, what makes our nozzle different, tie everything back to the outcomes the customer cares about, the performance, the reliability, the operating cost. When you get into technical discussions, this demo becomes an anchor. Instead of explaining abstract concepts, you can point directly to the component and say, this is where that performance comes from. People believe what they can see, and even more, they believe what they can experience. Integrate this demo into your sales process. Try not to skip it. Use it to create clarity, build confidence, and differentiate in a way competitors simply can't. Because when the customer sees it working in front of them, the conversation changes. Something that may seem simple on the surface, but has a direct impact on how we attract and engage opportunities, is our newly designed pull-up banner for trade shows and consulting engineer lunch and learns. In a trade show environment, sometimes you may only have seconds or maybe a couple minutes to capture attention. These banners are designed to do exactly that. They provide clear messaging, strong visuals, and focused value propositions that answer one key question immediately. Why should I stop and talk to you? At Lunch and Learns, the dynamic shifts. You're dealing with consulting engineers, highly technical, time constrained, usually only, sometimes 45 minutes to an hour to get your message across. And often they can be skeptical of anything that feels like a sales pitch. Here, the banners serve a different purpose. They reinforce credibility and structure the conversation. Remember, consistency builds credibility. When a customer sees the same messaging at a trade show and then again at your lunch and learn, and then later in a design proposal, it reinforces that we are structured, professional, and deliberate in how we go to market. Another part of how we show up to the market is our brochures, as well as our YouTube video content. These are not just supporting materials, they're extensions of us, especially when you're not in the room. Our brochures, whether physical or accessed through the website, are designed to clearly communicate our value, our capabilities, and our differentiation. The same applies to our YouTube video content. But this is where you can really elevate the approach. The video builds understanding faster than text. It shows motion, performance, and real-world application in a way, brochures simply can't. This is especially powerful when explaining things like mixing behavior, system operation, or installation context. Use videos strategically throughout your sales processes, and remember, these resources scale you. You can't be everywhere at once, but your content can. When used correctly, it keeps deals moving even when you're not actively engaged. Integrate brochures and the video into your workflow and use them to reinforce, clarify, and extend your messaging. Before we wrap up here, there's a nice little photo. Other manufacturers of these coarse bubble systems utilize PVC piping and light duty supports similar to fine bubble aeration systems for the sole purpose of being the cheapest system against competition. The process fluids where coarse bubble mixing is required are high solids and very viscous, requiring high energy mixing. The piping systems must be built to handle this high hydraulic loading on the system. Tideflex manufactures all systems out of stainless steel and strong anchoring methods. You won't see engineers sitting on other manufacturers' piping systems, like in this photo. Tideflex has the highest material quality and operational performance in the industry in this space. Thank you for the time today, everybody. And with that, do we have any additional questions on marketing these three systems? I know we got a couple questions entering the chat box towards the end of the presentation here. Jeff, I think it'd be okay if you want to come off mute and if you want to answer some of these questions.
Sounds good. I was checking one here from Gino's talking about applications where we've got ice buildup on intakes, water intakes. That's a specific application. We do that. Those fall under the air curtain type applications in there. And again, depends on how big the application is. That's a good area to talk about. I made a comment on the previous one that most of these tanks we're looking at are 300,000 gallons or larger than that. If you get really small tanks, the engineering cost becomes top heavy versus the equipment cost. And in the end, sometimes the customer says, I don't want to pay all that for the system in the small application. So we address that right away. So it really helps you guys to focus on the large applications, which is really where we're going to generate the most money. And there's no reason we shouldn't start at the top end of them, because all of that market's available to us, and then work our way down from there. And Scott's asking what type of connection styles are used to connect the piping systems together. We use, as you see in this photo there, that's a plate flange. Our piping in these systems is a Schedule 10. The blower pressure, when they design the blowers, they design just enough pressure to get the bubbles out under the hydrostatic head, which is about 95% of the head on the system. The remaining head is the losses through the pipe and through the diffuser, which is the last 5% of that. So these are low pressure systems. You're probably seeing 10 psi at the pipe itself. So we're using all 50 psi or less connections on that. So it's going to be either a plate flange, or it's going to be for the 4 and 3-inch smaller piping. We utilize Victolic RX couplings on that. You saw that on the channel assemblies, the smaller piping. The quick connect couplings are preferred by the customer for future maintenance, as well as the installation engineer. Very easy to put together. And any of the clamps you're seeing on the supports there, again, that's just a riser clamp type design, a bottom clamp, top clamp. And then we also have the lateral stabilizer bars. A lot of competition out there, as Nick mentioned. They've designed their coarse bubble systems as a offtake from their fine bubble system materials. Fine bubble systems are very low energy mixing systems, so the support structures can be very light. When you start to use threaded rods, it's a 1/2-inch diameter and only one rod. We see them doing that. Their pipe moves all over the place and typically has a fatigue associated to it. So our threaded rods are 5/8-inch diameter, minimal size, and on the larger pipes, they even move up to 3/4-inch diameters. So again, you see this engineer sitting on this pipe, he wouldn't have sat on this pipe if he hadn't already realized how sturdy these systems are and how we're able to stabilize the system.
Very good. I am not seeing, I believe we've answered all the questions that have been sent inside the chat box. We'll hang on here for, another 30 to another minute to see if any other questions arise. Otherwise, if no more questions do arise, we appreciate you taking the time out of your day to attend this webinar. It's a very exciting initiative that we've got going, and the amount of opportunity that is in this space is I don't want to use the word limitless, but there's a lot of opportunity, and we're really excited for some of our reps to hit the ground running with this.
That's a good point, Nick. One other thing is, we've been through this sales approach with new reps 20 years ago when we launched the program. Most of our representatives were valve salesmen, and all they had in their package were valves. And with these systems, all we asked was basically they expose them to the engineer, because as Nick's shown and Jeremy's shown, the features stand out apparent above our competition in any other methods over the last 50, 60 years of coarse bubble mixing. We have that integrated into it. Our engineers see right away that this is something worthwhile looking into. And through the support literature we gave you, the installation photos, they can see the systems. They can see applications that they've missed on that they realize they should have put these systems into. So don't get too bogged down on feeling like, even though this is a heavy engineered system, we take care of that for you. All you really need to do is find your environmental engineers and expose this product to them, and you'll see how really easy it is to sell and promote the product.
All right, doesn't look like we have any more questions. Again, appreciate you taking the time out of your day to attend the webinar. And I hope everyone has a great rest of their week.